XGBoost. It's a super smart algorithm that builds decision trees step by step, learns from mistake and prevents overfitting, works very well with big messy real-world data. Let's take an example. Let's do an analysis with XGBoost with the size of the house in square feet given and what will be the actual price in lakhs. On the left, the size of the house is mentioned in square feet and the data for the actual price in lakhs is mentioned on the right side. If we clearly see, the price is 0.04 into the size for all the data. When we have to do the analysis with XGBoost, we need to do few steps. First, we start with simple prediction, calculate the errors, which is also called as residual. Third step is train first tree on errors. Fourth step is update the predictions. And fifth, repeat it again and again. Let's do a simple prediction. Let's find out what would be a guess of the price of the houses depending on the size. So for that, we will take out the average price of the house. With our data set, the average would be addition of all the prices, which is 20 plus 40 plus 60 plus 80, divided by the number of data sets, which is 4 in our house. So the average price would be 50 lakhs. So the Y prediction for all the houses is 50 in this case. Let's move on to the next step, which is calculate the errors. Errors are the residual. Errors are actual minus predicted. Let's write down the entire data set once again with the size, actual, predicted and the error column. Error, which is the last column, will be the difference between the actual and the predicted. So the first case, it is 20 minus our average price, which is 50. 20 minus 50 is minus 30. In the same ways, we'll complete the entire data set calculation. Now let's move on to the third step, which is train first tree on errors. Now a small decision tree is trained to predict these errors or residuals. For example, if size is less than 1000 square feet, the predicted price is minus 30. If size is less than 1500, the predicted price is minus 10. If size is less than 2000, the predicted price is plus 10. Else predicted price is plus 30. Let's move on to the fourth step, which is update the predictions. New predictions is equal to old predictions plus learning rate into the error tree. Let's again write down the entire data set. We have seen about the size of the house is 20, 40, 60, 80 and on average we have found out the prediction to be 50, which is the old prediction. And the error tree, we have found out that it is the error between the price, old prediction. New prediction is equal to old prediction plus learning rate into error tree. Let's assume the learning rate is 0.1, which is small steps in this case. So our calculation will be old prediction is the average price of all the houses, which is 50. The learning rate, since we have taken small step, it is 0.1 and the error tree, so our calculation is 47, which is the new prediction. Likewise, we'll calculate the new predictions for all the data sets. Let's move on to the next step, which is repeat the analysis again and again. So we're going to repeat this step for the second iteration. So for first iteration, I've mentioned the table again, which we had done in fourth step. So 47, 49, 51, 53 are like our average which we took out in the initial step. So now we are going to find out the difference between the actual and the new predictions after the first tree. So 20 minus 47 is minus 27, likewise minus 9, plus 9 and plus 27, the difference between the prediction and the new error. In the second iteration, we are again going to find the new prediction, and this new prediction is equal to old prediction plus learning rate into residual. Our old prediction done above is 47 plus the learning rate is 0.1 into the difference between actual and predicted value, which is 47. So 20 minus 47, and the total comes to 44.3. So in the second iteration, we have the answer of predicted value as 44.3. Likewise, we'll do this calculation for all the data set. So for the second iteration, we have these values, the predicted values. We'll do this calculation for the third iteration and the fourth iteration. So with every iteration, we are first going to calculate the residual and then the new prediction, which is old prediction plus 0.1 into the error. The summary of predictions tells us that with the increasing number of iterations, we are getting closer and closer to the actual value of the data.